MDM4U 7.1 probability distributions. So the first thing we're going to do is distinguish between discrete variables and continuous variables. So in probability experiments, we're often measuring some outcome. We call this the random variable. And that numerical value can fall into one of these two types. It's either discrete, so it have values that are separate from each other, and the number of possible values can be small. So an example is the number of phone calls made by a person. So those values, they could have 0, 1, 2, 3, 4, so on. But between any two values, for example, between 1 and 2, you can't make 1.5 phone calls. So they're separate. Whereas continuous variables have an infinite number of possible values in a continuous interval. So the length of time the salesperson spent on the phone. So they could spend between 1 minute and 1 minute 1 second. But even between those two moments in time, there's still a midpoint, a value that exists between those 2 points. And there's an unlimited number of values between, for example, 0 and 1 second. So there are not separate values. It's on a continuous interval. All right, a random variable is a variable whose possible values are numerical outcomes of a random experiment. The probability distribution of a random variable refers to the likelihood of each possible outcome. So when I say each possible outcome, that's important because using this example, a probability distribution from randomly drawing a number from 1 to 5. Each of the outcomes are equally likely. And you can see here that each of the outcomes, 1, 2, 3, 4, 5, are on our graph. So we're interested in the likelihood of every single possible outcome. So speaking in general, a uniform random variable has equal probability for each of the outcomes between A and B. So the chances of a particular outcome is 1 over n, meaning the number of outcomes that are possible. This is just saying that the sum of all of the outcomes, if you remember sigma notation, will add up every single value of x, or the outcome that is possible. It will add up to 1, just as 1/5 added to itself 5 times is equal to 1. So the expected value. Expected value is an expectation or expected value denoted as expected value of x is the predicted average of all possible outcomes of a probability experiment. So this is the formula. Expected value of x is equal to the sum of x, meaning what the outcome value is, times the probability of that outcome, x. And that's for each of them. So if we were to use an example using a die, 6-sided die, the outcome x for our first value is 1. Its probability of 1 is 1/6. Then using sigma notation, we go to our next value. We'll update that to be the next value, which is 2, and its probability is 1 out of 6. Then 3, the outcome of that value is 1/6, and so on. So one interesting result is that we get the value, or the expected value, to be 3.5, which doesn't actually belong in the set. You're not going to ever roll a 3.5. However, this is a expectation. It's the numerical middle of the outcome. So if a game is fair, the expected value is 0. So you may see this in some of our homework questions. Please try the following, and best of luck.